So in the uninformed search strategy, we have, what are the information that we have? We have the initial node information. We have the goal node information. We have the cost between two states, and we have number of actions. Okay. The same informations are here also in informed search, but there are some additional information. That additional information is called heuristic information or heuristic. So heuristic is nothing but some sort of extra information that has been provided for finding out the solution. And instead of using the uninformed search, sometimes we use the informed search. The reason behind that is because the informed search because it has some additional information like heuristic value or heuristic evaluation functions. So because of that, it gives us the result very quickly, or will get the result with less time complexity. So this section shows how an informed search strategy, one that uses problem-specific knowledge beyond the definition of the problem itself, can find solution more efficiently than can an uninformed search strategy. So it is clearly mentioned that the solution that will find more efficiently. More efficiently means we may have less time complexity, as well as we may have less space complexity. Okay. So previously we have seen some problem. Let's say the 8 puzzle problem. In the 8 puzzle problem, the complexity of finding out the solution of the 8 puzzle problem is around this the time so the time complexity is b to the power of d. B is the branch factor, and d is the depth of finding of those solution. And if you'll find out the state space in the state space diagram, different state space is around 3 to the power of 20. So you can see these much of state space are possible with 8 puzzle problem. So what is the 8 puzzle problem? You might have seen that. So we have different tiles, and these tiles maybe they are in the position, or maybe they are not in the position. And what is our objective? Our objective is to find out the correct solution. So let's say this is the starting state, and we have to reach our goal state. And let's say this is my goal state, where every tiles are in their position. So from this starting state, how will reach the goal state? So from here, if we slide down the 5, if we'll slide down the 5, this is one state. If we'll slide 8 here, this is another state. So there are 2 possibilities that are possible. After that, if we slide down this 5 here, so space will be created here. So we have 3 possibilities now. 1 could be here, 5 could be here, and 4 could be here. So there are some other possibility after that. If we slide 8 here, so we have 3 possibility. We can slide 4 here, 7 here, and 8 here, right? So from here we have another 3-4 possibility. So which particular state in that way, when we go on and on, so it will be always we have around 3 stages which we can move that particular blank spaces. So that tiles could be moved maximum 3. So 3, and we have spaces around 20s. So in that way, the state space is, and it is very huge. If we'll increase the problem to, let's say, 15 puzzle problem, and the tiles value will be increased up to 15, then it will be around 10 to the power of 13, the state space that is possible. The same, if we'll increase a little bit more the puzzle space, it will be around 10 to the power of 24. So it is exponentially growing, right? Or if we'll, let's say, the chess problem. So what are the different possibility to be checkmate, right? So for that particular problem, around 35 to the power of 89, sorry, 79, around 80 possibilities are there. So you can see there are state space which are very huge. And to finding the solution in these state space, it is taking a lot of time, and it is taking a lot of memory spaces. So these type of problem comes into the category of NP, non-polynomial problems. The problems which we cannot find the solution in polynomial time, and whose solutions we can generally find in exponential time. So with the help of heuristic, with the help of some more information, we can lead these particular problem, or we can get some polynomial time complexity. So this is the objective of informed search or heuristic. So I think you are getting the problem that we have with the uninformed search. In the uninformed search, as I told you, for different problems, if we'll apply any of the uninformed search, it is taking a lot of time and a lot of spaces. To reduce that one, we have another category of searching strategy, which is called informed search or heuristic based search strategies. These heuristic or these informed search strategies, we provide some more information other than the basic information, and we'll try to find out the solution as quick as possible. So that is a response, that is a possibility that we'll get if we are using informed search. But the thing is that what is the problem here is, if we are using uninformed search, we'll get the optimal solution all the time. Means the optimal solution we can get all the time. That is the advantage of uninformed search. But if we'll use the informed search, so we may get the solution, which is called good solution or quick solution, but it may not be the optimal all the time. Okay, so that is the issue behind informed search, because we are getting the solution quickly. It may be the optimal, it may not be optimal, but it is a solution. But definitely, if we're using uninformed search strategy, we'll get the optimal solution all the time. Okay. Now, why we are satisfied with non-optimal solution? We are getting the solution, but they are non-optimal. Why we are satisfied? We are satisfied because it is taking less time. See, it is taking a lot of time, lot of spaces to get the solution. So why not we'll get those path, those solutions which may give you your solution, but it may not be the optimal solution, or it may not be the best solution. Okay, so we are compromising somewhere, and we are gaining something, right? So we are gaining that the time complexity will be less, the space complexity will be less, but we might get the non-optimal solution, or we may get the good solution, but it may not be optimal solution. Okay, so let's dig into the heuristic, and let's see what do you mean by heuristic. Okay, because heuristic is a new term for you. So let's talk about the heuristic. Okay, so this is the difference between informed and uninformed search. So let's quickly go through these, what should be the difference. So search without information, right? Here we have some information, input has been given, some other information has been given. No knowledge, will use the knowledge to find a step to the solution. So in the uninformed search, what will happen is we have the state space, and we'll go blindly wherever in a greedy method, wherever we go, we find out the best way, we'll go it blindly. But here what happened in the informed search, we use some knowledge, the prior knowledge, which I told you, the prior information, the heuristic value. And based on that, we'll take the decision that we have to go in that particular step or no, or we have to go in that particular direction or not, right? So that knowledge is there, which is responsible for giving you the quick solution. And here definitely the time consumption will be there, because we have a huge state space values where we have to go one by one and find out whether it is a goal state or not. Here it is, the time and space complexity are more. In the informed search, the time and space complexity is less. There are some example, like we have seen depth first search, we have seen breadth first search, we have seen uniform cost search, then iterative depth first search, and then depth limit search. So there are different searching algorithm that we have learned. Now here we are going to see different categories of searching strategy in the informed search, which are A star search, recursive breadth first search, best first search. In that way, we'll see different strategies here. So now talk about heuristic and heuristic function. What do you mean by heuristic? Okay. So the purpose of heuristic function is to guide the search process in the most profitable path among all there are available. Now, what is the use of heuristic? So if let's say we have the state space, we have these state space, and in this state space, let's say this is my goal state. This is my goal state. Now, if the cost here is, let's say 1, and the cost here is, let's say 5. So generally, which particular node will explore in the uninformed search? Because it is a blind search, right? These information is there. So generally, we used to explore this. Why? Because the cost is less. But because the goal resides here, so we have to explore this particular path, even though the cost is high. So those extra information will be provided in the problem so that we can decide whether we have to explore this particular node or this particular node. That will be done by the heuristic function. So heuristic function will guide us that which particular path has to be chosen so that we'll get the solution. We'll get the solution. And that solution would be give you the profitable path. A heuristic value evaluation function that is denoted as Hn. Heuristic evaluation function, which is denoted as Hn, is the cost of cheapest path from the state at node n. What is saying is the cost of cheapest path from the state at node n to the goal state. Now Hn. So here, if we'll talk about the same diagram, if we'll talk about, so let's say we want to go to the goal state. This is my goal state. And what I am doing is, let's say this is node S, which is a starting state. This is node A, this is node B, this is C, this is D, this is E, and this is F. F is my goal node. Now, the heuristic evaluation function will give you the value, and that value will tell that from S to the goal node, this is the estimated cost. So that value has been assigned. Let's say from this particular node A to the goal node, let's say this is the estimated value. Let's say from C to the goal node, let's say this is the estimated value. From D to the goal node, let's say this is the estimated value. From B to the goal node, let's say this is the estimated value. From E to the goal node, let's say this is the estimated value. Let's assume that. So this estimated value, based on that estimated value, if we'll take the decision, that will give you the solution at very quick time. So we doesn't have to explore each and every node into the state space diagram. And with this additional information, we can achieve our goal, right? So that particular evolution function will give you the cost that from the goal state, if you are in the goal state, if you are in any of the state, so to reach goal state, what should be the cost? So that is the estimated cost or approximate cost, or that cost may be guessed by some methods. Okay. So the heuristic evolution function, which accurately present the actual cost of getting the goal state, tells us very clearly which node in state space is expand next. The leap to quickly to the goal node. So how we can quickly go to the goal node, that will be decided by the heuristic evolution function, which give you some, which is giving you some actual cost to getting it. But the thing is that actual cost we can get if we have already been evaluated the cost. But the thing is that we haven't evaluated the cost earlier. So we'll use some methods which will give us the estimated cost, which will give us some approximate cost, or which can give us some cost that we can assume that this must be the cost. So in some mathematical problem, let's say if we'll tell you that that for 2 apple, the cost is, let's say, 20. So find out the cost of 1 apple. So generally we assume that, let's say, the cost of 1 apple is X. So that X, what we are assuming is a variable there, but here we have some value, and that value may change. That value may change because it's not the actual value or actual cost that we are having, right? So we are just assuming it. So for assumptions, we have many techniques which we can use. And by using those technique, we can actually apply some heuristic function on it, and we'll get some values. So the first method is called a straight line. It is also called triangle inequality theorem. And then we have Manhattan distance. So we'll see one by one these two methods to find out how we can have the heuristic value. Okay. So let us talk about the first one, which is called straight line. So we have different problem. Let's say we have this city problem, right? So from Arad, we can go to Sugoi. From that, we can go to another city. And from that, we can go to another city in that. And then we can go to the Bucharest in that way, right? So what happened in the straight line is from this point to this point, if you are going straight way. So let's say if you want to go from here to railway station, Bhubaneswar railway station. So we have to take the path, like from here, I can go to here, and then I can go to here, and then I can go to here, and then I can go to here. So for that, we'll have the other technique that we'll see. But from here, if I want to go here and I want to take a straight line distance from this point to this point, that is the straight line distance, and that could be evaluated using Euclidean distance. So in the Euclidean distance, what happened from one point to then another point? What is the distance, the straight line distance? So let's say we have a point and I want to go to that particular point, and we have many other paths, right? From here I can go here, from here I can go here, from here I can go here, from here I can go here. So there are different path available. Which particular path has to be chosen? So that will be decided by this straight line distance. So let's say from here to go here, let's say this is the value that we have is x1, y1, the point. This is, let's say, x2, y2. This point will be denoted. So with the help of Euclidean, we can find it out the Euclidean distance as square root of x2 minus x1 whole square plus y2 minus y1 whole square root over is the Euclidean distance that we can find out the straight line between one point to another point. So that particular value, we can put it here. Let's say this value is 10. So in that way, we can decide that from this point, let's say this is 8. From this point, let's say this is 11. From this point, let's say it is 12. Right. So from one point to the goal node, what is the distance? The straight line distance that will be calculated using different methods, straight triangle method, triangle equality theorem, or Euclidean distance that we can apply, and we can find it out some value. That value, based on that value, will decide that where we have to go. So definitely from all these paths available, from one point where we can go. Can we go here? Can we go here? Can we go here? No, we'll have to go here because it will give you the least cost, or the heuristic value is very less here. Okay, based on the straight line or Euclidean distance. Now the next method is the Manhattan. I hope you got the what is the meaning of heuristic here is. Heuristic means some extra information. So that extra information I can get from the straight line distance or Euclidean distance methods. So here the cost is there. This path cost is there. This path cost is there. But from here to here, what is the cost? 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 Right? So straight line, what is the cost? That we can estimate. Next is Manhattan distance. Now, in the Manhattan city, the roads are like this. Okay. So the path of the roads are in that way. So this is the road that we have. Right. So from here I can move here in that way. I can move here. I can move here. So there are buildings. There are blocks. But this particular line is my roads. So if I want to go from that particular place to that particular place, how I can move? I can move from this road to this road, this road to this road, this road to this road, and I can reach my destination. Or let's say I want to move from that particular point to this particular point. So where I'll go from here to here, I can go from here to here, I can go from here to here, I'll go. I'll just choose. So here, in that way, I can reach my destination. So this particular distance is Manhattan distance. It's called Manhattan distance. Okay. And this Manhattan distance we can find out with different applications that depend upon different applications. For the graph or the tree applications, we'll use the straight line distance. And we have the problem like 8 puzzle problem where we have tiles, 8 tiles. Okay. So for that, we'll use this Manhattan distance. So how we'll calculate the Manhattan distance in the 8 puzzle or in the 15 puzzle problem where we have the tiles available and we have to reach from one goal to another goal. So for that, let's say I have given you the solution for the problem for that. Let's say we have some tiles which are in the position which are not at all in their position. And what is our goal state? Our goal state is this. All right. So this is my goal state. This is my initial state. So from this initial state, I need to reach this particular state. So for that, if I'll use the Manhattan distance and I'll find it out like how much distance it will take, this tile will take to reach its goal state. So because it is in the same state, so it is 0. From here to here, so as you can see that the position 3 should be here, but it is here, so it is 1 movement. 2 position is also should be here, it will be 1 distance. 5 should be here, it should be 1. 6 should be here, that should be 1. 4 should be here, so it is 1 and 2 distance it has to cover. Then 8 is in its right position. 7 has to move 2 and 8 doesn't have to move, it should be here. So that particular value, which is 1 on 1, is 3 4 5 6 7 8. This is 3 4 5 6 7 8. So 8 is my heuristic value here at that particular state. 8 is the heuristic value here in that particular state. Now let's say we are moving from this state to some other state. Let's say 5 will be moved here. 5 will be moved. Let's assume that 5 will be moved here. This is my one state. So this will become blank. So how much is the heuristic in that particular state? So that we'll find out. Let's say this is 10. If we are moving from that particular 8 to here, then what are the state? So we'll calculate the heuristic of it. Let's say this is 9. Let's assume that this is 9. So in that way, do we have to explore this particular side of state space or this particular side of the state space? So definitely the heuristic value is less here. We'll explore that particular side of the space, state space here. So you can see for making the decision whether we have to explore this side or this side or which node, it is based on some heuristic value. Or you can calculate the number of tiles which are in the position, right? So that also could be the heuristic. Let's say this is 1 and 1. It is in their position, right? It is in their position. 2 is in their position, no. So I'll calculate 1. 3 is in their position, no. I'll calculate 1. 4 is in their position, no. I'll calculate 1. 5 is in their position, no. I'll calculate 1. 6 in their position, no. I'll calculate 1. 7 in their position, no. I'll calculate 1. So what is the heuristic value? 1, 2, 3, 4, 5, 6. So 6 is the heuristic value here. Because 2 and 3 are not in the position. 5, 6, and 4 are not in the position. And 7 is not in the position. So those tiles which are not in the position, I'll make the heuristic of it. So let's say this heuristic will become 6. So I can take any of the heuristic. So 8 may be the heuristic, which I told you that how many movement has to be done, or the tiles which are not there. So any of the heuristic you can choose to find out, and which will give you the solution in an optimal way or quick way, right? So there are the heuristic, finding out the heuristic value. We have some methods that we can use. One is called a straight line method. With the help of Euclidean distance you can do, and Manhattan distance you can apply to go from one state to another state. So what should be the cost, estimated cost, or what should be the guess cost? What should be the approximate cost, right? It is not an accurate cost, definitely, but it will give you the extra information so that we can make the decision which particular node has to be explored next. Okay. The whole game is which particular node has to be explored next, which particular road has to be explored next, right? So let's say if I am in triple IT, if I'll go to one cross where we have a road here and we have a road here, this will take you to the Katini Chak, and this will take you towards the some hospital. So which particular path I should choose? Because I have this particular one node, intermediate node, this particular one node, I need to go to the railway station. So from the Katni Chak, it will take me to another way. It might take me to another way. It might take me to another way. And then at last, it will take me to the railway station. Now, from the some hospital, I can go to where on the Studio Chuck, and then I can go to the CRP, or I can go to the fire station, and then I can go to the Gopabandhu Chuck, and then I can go to the governor house, and then I can reach to the railway station, right? So which particular path is giving you the less cost, right? So generally I move here. I move here. Why I'll move here? Because I have extra information. Like, what are the extra information? If I'll go from that particular direction, definitely I'll reach early. If I'll go in that particular direction, definitely it will take a lot of time. So that particular extra information is there in informed search to make the decision whether we have to go to the left or we have to go to the right. Right. So that is not there in the blind search. So in the blind search, we have to explore all the paths. So let's say we'll go here. If we are using some greedy method, let's say it is taking, let's say let's say it is taking 5 kilometers to reach some hospital, but it is taking 3 kilometers to reach the coordination. So where I'll go? Definitely, if I'm using blind search, so I should go to the least cost destination, that is Katanishak, and then maybe it will take 3 kilometers from reaching to another destination. Maybe it is taking 6 kilometers to reach another destination. Definitely, I'll explore this, right? So what I'm saying is the blind search will give you the solution. Definitely, it will give you, because it is exploring all the routes, but it will give you the optimal solution. But the thing is that it is taking a lot of time. It is taking a lot of space. But here, with some extra information in the informed search, we can reach our solution very quickly. So that is the difference between informed search and uninformed search.